Okay, this is 4.1 polynomials, and this is part 2. One thing that I wanted to make sure that we're real clear on is that functions that have negative or fractional exponents related to them are not considered polynomials. And if you stop and think about it, that's sort of a given since we're talking about whole numbers being the exponent. But I want to just highlight one little thing here. It says functions that have exponents that are negative or fractional when reduced to the lowest form are not considered to be polynomial functions. And I want to emphasize that because if you look at something first glance, you may discount it when in fact you need to just reduce it. So in this case, I have 3 over x plus 4. It's not a polynomial because when I go ahead and get it all on one level, it's going to be a 3x to the negative 1 plus 4. All right. However, this is when you have 3x squared over x plus 4. This is a polynomial because when we go ahead and reduce the x's, we wind up with a 3x plus 4. That is completely legitimately a polynomial. So if you have something where, say, our next one here, we have the square root of the quantity of 10 plus, or x plus 10, that is not considered a polynomial because we have an exponent of 1/2. Right? There's nowhere that we can have that. We have no way of being able to use that as a polynomial. However, this is again this case of reducing. If I take the cube root of 27x cubed, we need to rethink this, okay? So 27, the cube root of that is a 3. And the cube root of x cubed is x. So this is actually a polynomial, even though at first glance you might think it's not. All right, so it's important to actually go through the process of working through the problem, getting it to its lowest possible terms. All right, so polynomial functions, there's a few things you need to know about them, one of which is that the graphs of those are very, very specific. You can have a lot of things happen, but there's a few that absolutely cannot happen. The function or the graph will not have a sharp point. All right, there's no sharp angles to this. It's going to have a curve, but it's not going to come to a sharp point and then change direction. It's not going to have an asymptote, and those occur when you have something where you wind up trying to divide by 0. As you approach it from one side, the asymptote goes one way, and then as you approach it from the other side, it goes the other way. So you wind up with this weird-looking functional thing here, right? This is part of the solution, and then this is the other part of the solution. So clearly, first of all, that it's not that way because it's discontinuous. It doesn't continue completely across. So that's another thing you got to keep in mind. Your polynomials have to be continuous. You also can't have it start somewhere on the line or as a function somewhere other than at negative infinity. If it doesn't work for somewhere further down the line, I mean, if you were to look here, you'd be like, oh, okay, that's a function. But once you start getting down here, all of a sudden it stops. It doesn't work anymore, right? And so our domain on this has to be all real numbers from negative infinity to infinity. All right. So just need to keep that in mind when we're sorting through some things. I do want to point out that we have what's called a leading term test. And hopefully we'll get through this first part before we need to go on to the next video. The leading term test talks about the overall behavior, the big picture behavior that you're going to have when you are dealing with something raised to a certain exponent. Okay, so if your exponent is even, right, we're raising our n to an even number, so you'd have n to the second or n to the fourth or n to the sixth, any one of those, anything that's even, if your a is positive, it's going to smile, right? I mean, we know this from quadratics, right? We have something that does this. We have our quadratic, right? And there's our positive. And this would be if we have a negative, right? So this is going to be for a negative. This is the basic function, the basic shape any even function is going to take. If it's positive, it will smile. If it's negative, it will frown. Okay? And that's true regardless of what our even number is. I mean, we could go to, n is 100, and still it's going to wind up having this kind of a shape. All right? It will either be this way or it'll be this way in the overall picture of things. Okay? I do want to point out that we have some parts here, this and this and this and this. What those things are telling us is that in the squiggle here, there's other things that happen. Okay? In a parabola, we're really clear. There's just nothing else that happens in a parabola. But the minute you hit something to the fourth, you may have some wiggle that happens, right? You may have something that it comes down and does this, right? And that's perfectly legit. It could honestly be that as a something to the fourth power, right? I don't know what exact function that would be, but it's it would be to something to the fourth power. So that would give you, here you have the overarching shape, right? Here's the big picture, right? So here, oops, my pen is deciding to do its own thing. So from here, I go along here, right? And I can see that I'm going to pick up over here and have the same kind of deal. This is going to be my overall shape. Now this part here is the squiggle, right? This is the squiggle that we're talking about here. We don't know what all happens, depends on, what the function is. There's this little window of space that things are weird, right? Things can be weird in there. But that doesn't negate the fact that the overall big picture is going to behave a certain way. In this case, for the odd, and I'm actually going to, because our lines have an x to the first power, I'm actually going to use line as the best way to think about this, because whenever I looked at this, I would always get myself confused about which way is what. But if you stop and think about it in terms of it being a line, right? If I go like this, right? Everybody looks at that and says, oh, my slope is positive, right? So this is an odd, and this would be a positive result. Well, if you take a look, this is exactly what happens, right? Yes, there's a little wiggle in there. Not going to worry about that over much. I just want to make certain that we understand what's actually going on. And so then when I have something like this, right, this whole downward slope, that means my slope is negative. This is negative. So I'm going to have something that is approximately a line, like going downhill. Okay? So this is really helpful to figure out what it is that's going to happen when you are looking at the big picture of the test, or big picture of the graph. All right, at this point I'm going to stop this video, and then I'm going to go on to the next one, and hopefully we will get through this by the third on the third quiz, or third film.